So my name is Krzysztof Pawlowski, and today I would like to share our experiences of developing serverless solution written fully in Java. I work at Polish branch of company called Merapar. At Merapar, we help clients transform to the cloud by designing and developing innovative solutions using AWS platform. Apart from that, I also teach students good programming practices, Polish-Japanese Academy of IT. I've been working in Java for the last 10 years, and recently I got interested in cloud solutions. So what we are going to talk about today, we'll start off with explaining what the serverless is. Then I will tell you why we've chosen serverless for our project and why we went for Java for this project. And then I would like to share the lessons that we learned during development of this solution. And in the end, I would like to share with you some of the best practices recommended by AWS guys. So let's have a small recap after today's great keynote by Arun Gupta, what the serverless is. So serverless computing is a type of cloud computing where you don't need to care about provisioning servers. You don't need to care about managing those servers. You can focus on writing business logic, and the cloud provider takes care of executing your code in the cloud. So let's have a closer look. How does it work in more detailed way? So imagine we have a client that wants to execute our function. So this client makes a call to serverless computing platform, and then serverless computing platform retrieves this function from some kind of storage. In our case, because it's AWS, we use S3 bucket for storing our code. So for Python, Node.js, you store the code, but for Java, it will be jar file. Then when this function is downloaded, then it's deployed to the server where there are execution environments inside the servers, and then the function is run by the computing platform, and then the result is returned to the client. So what we need to take care of is to implement this logic, put this into some storage, and the rest is handled by serverless computing platform. So our responsibility for running this code is minimal in here. So because we are talking about AWS and Java, so let's have a closer look how it works in AWS using Java. So first, for this server from previous slide, we have EC2 instance, where the execution environment is running. So in our case, it will be JVM inside this execution environment. And again, we are only responsible for what we can see in this white box here. So we need to implement request handler, which is actually the logic of our Lambda function. So we need to implement this request handler interface, which is delivered by AWS SDK, and there in handle request method, we have the body of our method that will be run in serverless environment. So what was our case? What was the project that we worked on for the last year? So our goal was to migrate several million users and devices to a new platform. And the users decided when they want to go for the migration, so we couldn't predict what would be the exact load of our application. So we had to come up with a scalable solution for this. So when the users decided that they want to go for the upgrade, we had to migrate both users to the new back office as well as the data. And after this part was done, then we had to also trigger the device in user house to upgrade the firmware. So we were thinking how to orchestrate this process, because you can see that there are quite a few steps to do. So we decided to go for the serverless solution. So we implemented migration service, which was developed using AWS platform. So we used API gateway for defining API endpoints. We used AWS Lambda for actually executing our code. Because the migration could be defined as a workflow, we went for AWS step functions, and it was the biggest factor that we take into account when we were choosing the platform that we want to use these step functions actually to define the migration workflow. So it allowed us to orchestrate our Lambda functions or the steps in this migration process using the solution that we got out of the box from AWS. We also use DynamoDB for storing the migration state in database, as well as AWS Elasticsearch and Kibana for logs. So because those services are also serverless, we didn't have to set up, for example, server for database. We didn't need to manage it. Also, the same goes for Elasticsearch. We could use Elasticsearch, which was managed by AWS. And because we use all the components from AWS, it was quite easy to integrate our code with those components. So the complexity was lower. And also, it was quite easy to integrate AWS serverless solution with other external services like this old platform and new platform from which we migrated the users. So why did we choose serverless? First of all, we really like the idea that we don't need to manage the servers, and we got quite a lot of services from AWS. So thanks to that, we were able to deliver first basic workflow in like 2 sprints, which was also good for the customer that could see the progress of our development quite quickly. Also, the deployment was simplified because we could use AWS CloudFormation, so we could define the whole application and infrastructure using one service. So we defined what should be properties of database, what should be the properties of the deployment of Lambda functions. We put this all into CloudFormation YAML files, and we could deploy this with one command on our Jenkins. Also, because we used fully serverless solution, and the scaling was done for us out of the box. We didn't have to architect for scalability. We just chosen those solutions from AWS, and we got it just as it is without much more development on our side. Also, because of the nature of this project, like I said, it was a migration process, so we more or less knew how many users we need to migrate, how many requests there will be for each of the migrations. So we really like the idea also that we pay only for what we use. So we paid for the request, so it was rather easy to give the estimation what would be the overall cost of the migration. And also we wanted to avoid situation when a user opts in for the migration, but the service is down. So we wanted to make our application highly available and fault tolerant. And also, again, because we went for serverless, we didn't need to architect for this, and we didn't need to bring up our infrastructure for that. It was also provided by AWS in our case. And why did we choose Java for our service? Because if you look at the reports, like 70% of Lambda functions are written in Node.js or Python. So Java doesn't seem like a natural choice for your AWS Lambda code. So it might sound trivial, but in our case, it was mostly because of the competencies in the team. So we were all Java developers, and you were wondering if we can use our skills in this project, because also serverless concept is quite new. So it would mean for the developers to pick up new stuff regarding serverless and also learn new language. It could be a little bit too much. So we wanted to make sure that we can still use our well-tested libraries that we know, like a Apache HTTP client. Also, in my opinion, I think that for more complex projects, strongly typed languages are better. So here there was a big advantage of Java. And also, AWS provides you really well-documented SDK for Java, so you can integrate with other AWS services in your code quite easily. And the other reason for choosing Java was that we really like the tooling that we were used to, like IntelliJ IDEA or Maven for building the application. OK, so once we've chosen that we want to go for serverless solution and we want to write the code in Java, there was the first lesson that we had to learn or answer the first question: what should be the project structure? So we had basically two options. We could go for one big Maven project where all the Lambda functions would be put into one jar file. Or the other option was to create a separate jar file for every Lambda function that we had in our application. So what are the pros and cons of each of these approaches? So for one big Maven project, definitely it's easier to build such a solution because the output is only one jar file. It's easier to deploy it. Also, we could reuse the code. But the drawback of such approach was that it took longer time to download and unpack the package, which had some consequences in the performance of our application. But we'll get back to this topic later during this presentation. So what would be the pros of using Maven project per Lambda function? First one is that we can deploy first only single functionality. Also, we have the code separation in such approach. So if we modify the code of one Lambda function, we can be sure that we didn't break other Lambda functions. So definitely this coupling between Lambdas is a great advantage of such approach. And also it has a little bit better performance. But the drawback of this approach is actually that there is a code duplication. So recently, AWS Lambda layers were announced. So probably if we would start this project right now, we would go for AWS Lambda layers. But we went for one big Maven project because, as I already told you, we had to develop the workflow. So those Lambda functions were rather coupled together in terms that output of one Lambda function was actually the input of the other Lambda function. So balancing that, that we also wanted to reuse the code, and it was a little bit harder to make it separate. We went for this approach, but if you need to make this choice, you always need to balance all those pros and cons of each of the approaches. Okay, so I said that we could use a lot of services from AWS. We didn't have to manage servers. We didn't have to provision them. So one might say that now all you need to care about is to just write the business logic. So you can just implement business logic code, and that's it. But where has the complexity moved to? So to answer this question, let's first have a look at how we would define the endpoint in Spring Boot application. I guess that probably most of you already did such a thing. You implemented the endpoint, if not in Spring Boot, then in other framework, but it's very similar. So here we can define what should be the method of this endpoint. In this case, it's post method. We also define what is the response status. We define the path to the endpoint, so we can do it all in the code using annotations. And then we have a method which is actually the implementation of this endpoint. So in this case, it's very simple. It just calls other service to create some object. So how the same thing would look like in AWS? So first, if you want to define an endpoint in AWS, you need to get to know at least 3 AWS services. So you need to get to know AWS IAM, which is a service for users, permissions, and roles management. Then you need to get to know a little bit about AWS API Gateway, which is used actually to define the endpoint definition. And then you need to also know AWS Lambda, which is actually running your code. So complexity has moved from one code base to multiple services, and initial bootstrapping of your application might take a little bit longer time. So if you want to do something as simple as defining the endpoint, definitely you can achieve that faster in solutions like Spring Boot. So let's have a closer look at this endpoint definition in AWS. So first, you need to implement your AWS Lambda handler. So if you look at this code example, you can see that it implements request handler interface from AWS SDK. And you need to implement a method handler from this interface. And basically, the implementation is exactly the same as we could see on the previous example from Spring Boot. But you cannot see any annotations above of this function. Yeah, so there is no metadata related to this endpoint. It's just a pure code of your function. So the actual endpoint definition goes to the service called API Gateway, where you need to provide quite a long JSON definition of your endpoint. So it's in OpenAPI format, also known as Swagger. So you need to define all the responses mappings, all errors mappings. I didn't put example here, which is quite long JSON, and it wouldn't fit the slide. So once you have the endpoint defined and you have your Lambda function, which is executing the code that should be triggered after calling this endpoint, you need to add permission for your API gateway endpoint definition to call the actual code in your AWS Lambda. So here you can see the example of such a permission that you need to provide a function name and also source RN for API gateway. And so basically you need to give permission to the endpoint to call the actual code. So those 3 steps needs to be done to achieve the same thing that we could see on one of the previous slides in Spring Boot. So now developer needs to know a little bit more about the infrastructure than before. Yeah? Because in many cases, it was like developer implemented the application in Spring Boot, defined some endpoints, wrote some documentation, but all the configuration of infrastructure was done by other teams. So now, as a developers, we need to know a little bit more about the underlying infrastructure and configuration. Okay, so we could see that if we wanted to have this endpoint defined, we had to use 3 services. So one might ask, but how now we can debug the application? Yeah, so the bad information is that there is no such thing as remote debugging for our AWS Lambda functions. So we cannot attach our debugger from, in our case, IntelliJ IDE, and we cannot track what is going on the remote instance. But we have something like AWS SAM for serverless application model, where we can run our application locally and we can play with it. So we don't need to deploy it to the cloud to test actually how it works. Also, we have Eclipse and IntelliJ plugin. One of them were presented by Arun Gupta during today's keynote. But the drawback of this AWS serverless application model is that not all the services are implemented there. Yeah, so you can see that there are many products added to AWS platform every year. And it's really hard to implement everything in this open source tool. So in our case, we use AWS step functions for defining the workflow. And back then, it wasn't yet implemented in AWS SAM. So what we had to do, we had to test those Lambda functions that we were developing in isolation. So we had to provide the proper input to these Lambda functions, like the input that would be provided by step functions service. So it was a little bit problematic, but it was doable. So let's have a closer look at this IntelliJ AWS toolkit. So when we install this AWS toolkit for IntelliJ, we can see that there is a new project type added to our IDE, which is AWS Serverless application. We can also configure which AWS region we want to use with this plugin. I will explain a little bit later on why we can need this. So here you can see on this slide that you can run your application locally, but also you can debug your serverless application or your Lambda function locally. So if there are any problems with your Lambda function, you can try to reproduce this error locally and you can debug it. So it's quite an improvement in how you develop Lambda functions now using this plugin. Yeah, when you tested your application, you are pretty confident that everything is running as expected. Then you can also use this AWS toolkit to actually deploy your application to the cloud. Also, you can run your application from the IDE level, and you can see the output of your Lambda function running in the cloud in your IntelliJ console. So now you have the tooling for IntelliJ IDEA, which allows you to develop your applications much faster. Everything's integrated in one place. You don't need to call command line tools or go to AWS console to deploy your application. Because with other languages like Node.js or Python, you could easily write this code in the console. You also have IDE in the AWS platform. But with Java, it was a little bit problematic because you always had to upload the jar file to the console, and then you could run it. So now it's much easier. OK, so regarding debugging, before you start debug, maybe it's worth to analyze what went wrong. So you can see if there are some information in the logs. So or look at the metrics. So what is good about using AWS is that it gives you quite good tooling for monitoring your application. So one of examples of such a service from AWS is CloudWatch, where you can create really nice dashboards with many metrics which are given you out of the box, so you can see how many times your Lambda functions were triggered, what were the execution time of your Lambda, what were the times that executions were most frequent, and so on. Yeah? So regarding our service where we wanted to migrate users and we didn't know what the expected load would be, it was really powerful tool then to monitor what is the current state of the migration, how many users already opted in for the migration, and so on. Also, we have a tool called X-ray, which basically draws the diagram of your application, so you can see all the interactions of your code with other services, how you can track your requests, you can see how much time your Lambda function execution took, which other Lambda function or other service was called by your Lambda function. What is more, it's auto-generated. There is a minimal configuration that you need to do. SDK takes care of this on its own. The only thing that you need to add is to add the permission to X-ray in the case of Java application. So what about logs? So this is also a tooling that is given by AWS. You have CloudWatch Logs Insights, which was announced during the last re:Invent in November 2018. And it helps you in searching, filtering log messages, which were stored in CloudWatch. So you basically have the same functionality that you have in Kibana. But still, if you like Kibana more, you can set up Kibana in your AWS account. You also need to set up Elasticsearch, but it's also managed by AWS. So there's still a serverless solution for this. And you can browse your logs in Kibana as well. So the good thing about those approaches is that they are all managed by AWS. OK, so now we are going to, I think, the most interesting lesson. Because when we were choosing Java, we had some doubts. What about the performance? Yeah, if this Java code be performant enough, what are the consequences of choosing the Java? As I said, the most common choice for serverless solutions is Node.js and Python. So this was the question that we actually asked ourselves before choosing Java. So to test the performance of Java in AWS, we run a simple application which exposes get endpoint, which returns only hello world response. So really like hello world of API definition. And we had this application written in Java, Node.js, C#, F#, Go, and Python. So we could have quite good comparison. We run these Lambda functions with 1 gig of memory. And what is important, we didn't take cold start into consideration when doing those tests. So we were running those, we were calling those endpoints 10 times per second for each of the languages for an hour. this is a diagram of 10 minutes of such executions. So we calculated, in this case, average duration of the Lambda execution over the period of 1 minute. So we can see that Java code had average performance. It wasn't the best, but it also wasn't the worst one. We can see that Golang went through this test the worst. But still the differences weren't such big ones, so we were quite relaxed about going for Java at this stage. If we are looking at the maximum duration over the period of 1 minute, so the same thing that we did with average, but here we are looking at the maximum execution time of this Lambda function over the period of 1 minute, we can see that Java code had quite consistent performance. We can see for other languages that there are some kind of spikes, but with Java, the line, which we can see also on a separate diagram below, is quite consistent. So this was based on only the execution of AWS Lambda code, but let's have a look how it behaved when we looked at the execution time of the endpoint implemented in those languages. So when we are looking at the duration of executions of the endpoints written in those languages, we can see that average time for the endpoint written in Java was very similar to other languages. We cannot spot the difference in here. Yeah? So you can see that all the requests were in between 12 and 14 milliseconds. Yeah? So even when we are looking at the API gateway response time, then it's very similar for all the languages. And also we can see that, again, Java endpoint had consistent performance. So we can see, again, quite flat line, where for other languages, this line had spikes. Speaking about the performance of your AWS Lambdas, it's good to know that you pay for each started 100 milliseconds. And the price depends on the memory that you allocate for your Lambda function execution. And depending on this memory allocation, you get CPU resources. So it's very important to find the sweet spot where the execution will take least time. So sometimes giving more memories, so it could be a little bit more expensive, will lead to cheaper execution of your Lambda function because it will be running much faster. But it's quite hard to find what is the best configuration for your Lambda function because it depends on many factors, like if there are many input-output operations and so on. So what we used is an open source tool called AWS Lambda Power Tuning, which allows you to set up the memory, configure what you want to test in terms of memory. So you can give, in this example, like I want to test how my application will work with, or Lambda function will behave with 128 megabytes of memory, then 256, and so on, up to 1 gigabyte in our case. We provide input for our Lambda function, and then we have a report after many executions, what was the best configuration for our Lambda function. So you can see on the right side that first two configurations with 128 megabytes of memory and 256 megabytes of memory were the best, but in terms of cost, they were quite similar. Maybe it can't be seen here, but it's exactly the same. But the execution time was much bigger in the first case, so it's better to go for the solution with more memory, given that the cost is the same. But if you look at the other results, then the improvement in execution time is not much bigger, but the cost is significantly bigger. Yeah, so this tool can help you to tune your Lambda functions so that you pay less, but you get the best performance. Okay, so I said that these performance tests were those performance tests were done, but we didn't include cold start in this. And First, let's start with the explanation what the cold start is. So when you start your, or when the serverless cloud provider is running your code, first you need to download the code from the storage, what we could see on one of the first slides. Then the execution environment is started. Then our runtime is bootstrapped, so all our classes are loaded and so on. And then there's actually the part of running our code. So first three steps are called cold start, as they happen for the first time. And then we have warm start, and cold start and warm start give us the total execution time of our Lambda function. So when can we observe cold start effect? So when we call the Lambda function for the first time, we can see that there is this cold start part, that our code needs to be downloaded, and execution needs to be set up, and then execution environment needs to be set up, and then environment bootstrapped, and then there's actually the part of running our code. But if we call the same Lambda function for the second time, we can see that there is only part of running our code. So AWS keeps the execution environment of our Lambda function up, and we can reuse that. So thanks to that, the execution time for the second time is much lower. So what happens if there is a quite big interval between our executions? So we can see that if the interval between the executions of Lambda function is above 20 minutes, then we will observe the cold start effect again. So this is not revealed by AWS how much time does it take to kill the execution environment, but looking at other people on observation, you can say that it's somewhere between 20 and 45 minutes. So we need to be really aware that this execution environment is not up for the whole time that our application is deployed. It gets killed after some time. So if our Lambda function is not called often enough, then we can experience this cold start effect. So what happens if we have concurrent Lambda executions? So here we can see that there was one Lambda execution on the first arrow, but then there was another Lambda execution which was done after the first execution of the Lambda. And we can see that the cold start effect was observed again. So when we have concurrent execution of our Lambda functions, there might be more execution environments started by AWS platform. So we also need to consider that. So it's not enough to have our Lambda function called quite often. We also need to take into consideration that if we have concurrent executions, then this effect can also be observed. Of course, we can limit the number of concurrent executions of our Lambda function, but then if we call this Lambda function many times, we can experience other issues, so it's not a solution to this problem. So why it is important for Java? So for Java, it is important because this cold start might take couple of seconds. So it's quite a big latency that we can get after the first start of our Lambda function, or for the endpoint which is calling this Lambda function. It's much less harmful in dynamically typed languages like Python and Node.js because the execution environment already contains all the libraries from Python and so on. And in Java, one reason is that also our jar file is quite big because it contains all other libraries that we are using. So if you're looking at the sizes of package for Java Lambda function, it's counted in megabytes, but for Python and Node.js, it's counted in bytes or kilobytes. So the difference in size is quite significant. And also, the bigger the jar file is, then the cold start is longer. So this is what I talked about with choosing these two approaches, if we should have one big jar file or many smaller jar files for our serverless application. So if you are experiencing the problems with cold start, then definitely you should consider going for smaller jar files. Also, increasing memory and also increasing the CPU resources for your Lambda function might decrease the cold start time, but it might cost a little bit more. And if still it's not satisfying enough, then you might consider to go for other language than Java. But how can we eliminate the cold start? We can pre-warm Lambda function by calling this Lambda function about every 20 minutes to keep it warm. So then, as we could see in one of these previous diagrams, if you keep your Lambda function being triggered more often than every 20 minutes, then you should have your execution environment alive. So you shouldn't experience a cold start effect. So one might say that, okay, but it might be expensive, yeah, if you're calling your Lambda function all the time for like a year. So I've calculated that, and given that you assign the biggest memory that you can assign to a Lambda function, and your Lambda function would run for 1 second, it would be still about $1 per year. So this is not an expensive solution. But if you have n concurrent Lambda executions, first you need to determine what would be the load of your Lambda in this case, and then you need to run at once n concurrent Lambdas to keep n concurrent or n execution environments warm. So still it's not the perfect solution, because what happens if someone calls your Lambda function when you are pre-warming this Lambda function? Then still the cold start effect will be experienced, yeah? So you cannot fully eliminate this cold start effect. But sometimes the solution could be do nothing, because sometimes this cold start is not an issue at all, because it doesn't hurt you if the response time is from time to time over a few seconds. Yeah? So in our case, where we had to migrate the users, and this process involved a lot of communication with other services, and the actions on IT side took like a few seconds, it didn't harm to also have a response time of a few seconds, because it was quite a long process anyway. So sometimes it's not an issue, and you don't need to care it, but you need to keep in mind that it can happen. So if low latency is a priority for you, then it might be good to think if Java is a good programming language for the Lambda functions. And the last lesson that I would like to discuss is to understand and use AWS best practices. So in many cases, those best practices, good practices, are like how you can do your code look better, and it's mostly about opinions. But in this case, we found AWS best practices very practical and useful in terms of how to develop your application, that it is performant, that it behaves as expected. So first best practice that I would like to present is take advantage of execution context reuse to improve the performance of your function. So what does it mean? So this execution context is created during the bootstrapping of your environment. And as we could see on previous slides, it's part of the cold start of your function. So if you initialize the objects that take a lot of time to initialize, like HTTP connection, database connection. So if you do this in static block of your code, or in constructor, or as static variables or singletons, then you can reuse those objects in next execution of your Lambda function. So it's generally the good approach when you're developing any application, not only serverless, but in case of serverless, because of this cold start and also costs of each request, is very visible. Other best practice from AWS is to use AWS environment variables to pass operational parameters to your function. So people who are used to Spring Boot application tend to put all the configuration in separate file. So we have a file where we keep our configuration, and then we can modify this config file, restore the application, and that's it. But in a serverless approach, where you have AWS Lambda function, if you want to modify the environment, then you probably need to redeploy your function because you don't have access to your execution environment. So here you can use those environment variables to make a configuration for your application. And then you can go to AWS console to modify those environment variables for your Lambda function. And then with the next execution of your Lambda function, the new configuration will be used. So this is the other way of providing the configuration to your application, but in AWS Lambda, it will be really easy to modify the config without the need to deploy your application. So the last best practice from AWS that I would like to present to you today is to be familiar with AWS Lambda limits. So first, AWS Lambda limit that we can see on AWS documentation is that you can have up to 1,000 concurrent execution of your Lambda function in AWS account. So we need to, if you have like an application, serverless application that you use for processing a lot of data and you need to start many Lambda functions in parallel, you need to be aware of this limit. Also, if you're doing the processing in your code, especially the processing that takes some time, you also need to be aware that there is a limit of the execution time of your Lambda function. So this limit currently is 900 seconds, which is 15 minutes. So if the Lambda function is running for more than 15 minutes, then it will be killed. Also, you can allocate up to 3 GB of memory for your Lambda function. So you need to keep this in mind as well. So probably for long processing applications, either you should use other solution or try to split the work so that you can fit those limits. So yeah, so you need to change the architecture of your application considering those limitations. Also, about what we discussed, we talked just a moment ago, the environment variables. So you can have up to 4 kilobytes of these environment variables in your Lambda execution environment. So if your config is much bigger than 4 kilobytes, then probably you need to consider if you should put this, for example, in database or in other kind of storage like S3 bucket. And also the temp directory of your execution environment can have up to 512 megabytes of memory. So this is also something that you need to take into consideration when developing applications. So going to conclusion, was it good to choose Java for serverless? Definitely yes. At first we were a little bit afraid if it will fit, given that not many people are using this. Looking at the various reports, we could see that between 5 and 10% of Lambda functions are written in Java, so it's not so much. But is Java always good for serverless? Here I can say that definitely not, because if you have priority to return a response with really low latency, then probably this cold start will be an issue for you. So when to actually use Java in serverless? So first of all, as I said, if the cold start won't be a problem, then it's fine. And yeah, our reason was that it was the preference for the team. So you're all, I guess, Java developers here. So you don't need to be afraid to use Java in serverless environment. You don't need to now learn Python or Node.js to start creating serverless solutions. So we couldn't see any other problem with using Java for serverless solution than this cold start time, which took longer for Java code than in Node.js or Python. So when to use serverless? When the load of your application is unpredictable. So it's much better because of the scalability that you get out of the box and is provided by AWS, so you don't need to architect your solution for scalability. And also if the load of the application, or if you want to start with a smaller project and you don't want to have a big costs, then if the load is really low, then the cost will be low as well. And also, yeah, if you have long-running processes, then probably with serverless you need to do it somehow different, and it might be harder. So thank you very much. It was really nice to speak to you today. We don't have time left for questions right now, but I would be happy to answer questions because I will be here around. So please approach to me if you want to discuss something. Thank you very much.